So we have the first activity, which is reaction of metals with cold water. So we are going to investigate or look at particularly what happens when metals react with cold water. Now I'm going to explain this theoretically, but I have uploaded a video which shows you how metals like sodium, potassium, magnesium, how they react with cold water. I've uploaded a practical video. So here I'm just introducing you to the theory bit of this practical. Then I've uploaded a practical lesson which shows you how the metal sodium, potassium react. Kindly look out for those videos. Now, what do we need? We need cold water. We need beaker. We need a beaker. We need sodium, potassium, magnesium, some of the common metals which you consider at this level. Now we are going to come up with a procedure. So the first one, place or power cold water in a beaker. Pour cold water in a beaker. Then cut a small piece of sodium metal. Cut a small piece of sodium metal. Cut a small piece of sodium metal. Cut a small piece of sodium metal and place it carefully. Cut a small piece of sodium metal and place it carefully in the water trough. And place it carefully in the water trough. What else now? Place it carefully in the water trough. So observe what happens. Observe what happens to the metal and record your observations. In the table. Observe what happens to the metal and record your observations in a table. Then repeat the procedure using other metals like potassium, calcium, magnesium, aluminium, record your observations. I want to tell you that I've uploaded the practical on this. Yes, I've uploaded practical videos which demonstrate this process. So we are just trying to go through it theoretically, but the videos have been uploaded on how this thing is done practically. So you pour a cold water in a beaker, then you cut a small piece of sodium metal, drop it in a beaker carefully, and then you make observations. Then you record your observations in a table. Yeah. So that is this is the experiment. This is the experiment. Now we are going to proceed with the observations. We are going to proceed with the observations. We're going to proceed with the observations. We are going to proceed with the observations. So we have our table here. Table of results. Table of results. Table of results. We have one column with metals and then observations. Now I'm going to request you to kindly watch those videos. You are going to observe some of these things which I'm going to write. Let us start with sodium. So we have a water trough. We have a water trough. Now in this water trough, we are going to carefully drop in a piece of sodium. This is sodium. You just drop it inside using a pair of tongues. By the way, sodium is very dangerous. Yeah, it's very dangerous, and this thing is also not good to conduct if you are in a closed environment. It has to be an open set. Yes, an open space. It has to be an open space because sodium, metals like sodium and potassium are very dangerous on exposure to the atmosphere. So it has to be carried out in a safer environment, an open space. Yes. So when this piece of sodium metal is dropped in a water trough, it's going to float. It's going to float as sodium reacts with the cold water. So what is going to be our observation? This sodium metal is going to you can watch the other previous sessions, the previous the practical bit of this thing. Here I'm just trying to go through the theory. Yeah, but I've uploaded the practical bit. So go through this theory, then after you watch the practical sessions. So this sodium is going to melt into a silvery ball. It melts into a silvery ball. Then it darts on water. It's like this clear water now will turn into dirty water. That's on water surface. melts into variable, that's on water surface. Then reacts violently, or you can say that reacts vigorously. That's on water surface, reacts violently or vigorously, producing a hissing sound. It melts into a silvery ball that's on water surface, reacts violently or vigorously, producing a hissing sound. Now, when you consider a small piece of sodium metal, we shall observe this. But if we consider a large piece of sodium metal, actually the reaction mixture will explode. Now, if the reaction mixture explodes, that shows you that sodium is actually very reactive with, or reacts violently with cold water. So this is the observation when sodium reacts with cold water. Now, when we proceed with potassium, for it catches fire, burns, burns with a purple flame, that's on water surface, and reacts very violently or vigorously, producing a hissing sound. So what is the distinction? Or what is the difference? Potassium reacts very violently or vigorously, and for it even catches fire if you use a small piece of potassium. But sodium, when you use a small piece, it will just melt into a silvery ball, reacts vigorously. But if you consider a large piece of sodium, then the reaction mixture will explode. It will kind of behave like a bomb or atomic bomb, something of that sort. The same applies to potassium. If you consider a small piece, it will catch fire, burn with a purple flame, that on water surface, then it will produce a hissing sound. Consider a large piece, you will be trying to make a bomb. Yes. I've uploaded this. I'll continue reminding you that I've uploaded practical sessions on how these things will behave.